Developing a project for Exhibit Columbus has been an exceptional experience. The installation of Calibrate is very exciting, but really the design process, collaboration, and opportunities to work with students, colleagues, and community throughout the installation, as well as the potential for expansion of future research beyond, are the essence that make this opportunity truly unique. As an assistant professor of landscape architecture in the College of Architecture and Planning at Ball State University, my main concentration is working with students to help build their expertise before they enter the field. I mainly teach studio and design communication classes, which focus on the process of crafting a design and how to communicate ideas from the initial outset to the analysis of supporting information to the design proposal. In addition to and in support of working with students, I balance building my research agenda, which focuses on how we understand landscape processes through use of technology. The process of the Exhibit Columbus University Design Research Fellowship is an opportunity to not only expand those research ideas, but also a fantastic opportunity to work in a different capacity with students, colleagues, facilities, and technology, ultimately providing a venue for expanding beyond what I typically teach in the classroom. After initial discussions on developing Calibrate, last spring I taught an elective course called Visualizing Systems, in which I called on students in the class to think about the different environment information that is collected through sensing technology, how we might develop ways to interpret that data, and how that data might be used in the design process. The class served as a precursor to Calibrate. Students looked at the variety of publicly available data collected from the environment, experimented with ways to visualize this information through graphic representation, collected precedent studies on drawing machines, how they work and what the inputs and outputs are, and experimented with sensors and microcontrollers to develop initial ideas about how to reinterpret data and potentially collect their own. Ball State University and the College of Architecture and Planning has a wide array of resources in terms of people, facilities, and technology available. Often through classes we might concentrate on getting familiar with one aspect of these in order to serve a particular assignment. The development of Calibrate enabled the team to work with several different technologies and spaces, as well as collaborate in different ways. The prototyping of Calibrate entailed working through various iterations, experimenting with different materials and techniques, and testing how to translate data into drawings. CAP's makerspace at Majax Muncie was essential with its array of tools, machines, excess materials, and knowledgeable colleagues. Some of the experimentation included testing the movements of the machine, the speed, and also the sound created by the movements. Different methods of releasing the drawing media through various mechanisms were also tested and continued to challenge. One of the greatest aspects of working on this project was getting to work as a team with colleagues and students in different capacities. The next segment documents aspects of the build, while highlighting the many amazing people essential to the project. Calibrate is a drawing machine choreographed by environment data. The terrain base, or canvas, is based on the landscape of Indiana and consists of 2 layers or systems. The lower portion of the model is derived from a mapping of groundwater availability, which are related to the aquifer system underlying the Indiana surface. The mapping creates a variety of containers, pockets, and channels. The upper portion is a 3D representation of Indiana surface geology, derived from LIDAR. It shows variation in elevation as well as variation in landforms shaped by glacial movement. Microcontrollers gather and recalibrate publicly available sensor data of temperature, humidity, solar radiation, precipitation, and river currents. The data is processed, translated, and recalibrated to direct the machine's movements. Above the canvas, a hopper stylus on a robotic gantry deposits and disperses media by those instructions. The recycled plastic grit media is typically used for sandblasting, however is also used for river sedimentation modeling. As the data changes, the media accumulates and repositions, continuously redrawing and remapping the underlying terrain. Being situated outside in the environment, the machine, the media, and the canvas are all additionally influenced by site-specific direct influences, such as sun and shade, ambient lighting, rain, wind, insects, birds, trees, humidity, and people. The gantry's movement creates a slow drawing, which might also be interpreted as kind of a performance that makes visible the interconnected ecological information that centers Columbus within a longer timeline. We can program data into a virtual simulator to get an idea of how the drawings will evolve over time. However, local variations can influence change. The nature of the machine, the exposure of the canvas, and the response of the hopper stylus to small adjustments in addition to the environment data and variation in the terrain all come together to create a drawing in motion over time. Now that the Exhibit Columbus exhibition is open, I am regularly asked what happens now that it's complete. However, I see this as just a beginning. The University Design Research Fellowship provides a significant opportunity to expand the ideas in Calibrate for future exploration. As an installation, there are many elements of the build that can be modified, from the materials of the canvas base to the operation of the machine coding and interpretation to the performance of the gantry and stylus. Beyond the build itself, though, the idea of bringing together multiple timelines and physical scales in order to illustrate and reveal hidden systems or visualize layers in order to understand our environment is part of my research that will continue to evolve.